Hello, this is Julia Burki from DecisionBrain. Today, I will demonstrate to you a solution we have created for Toyota Thailand to optimize their inbound logistics. This solution has been up and running for over a year now, and it has been proven to bring down costs by 10 to 15%. Let me briefly introduce my company, and then we will jump on the demo. DecisionBrain is a leading company in advanced analytic solutions based on advanced mathematics. It was founded less than 10 years ago by two optimization experts, Filippo Focacci and Daniel Godard, formerly from iLog, hence the 30 years of experience. We are an IBM partner for technology as we develop the platform IBM Decision Optimization Center, and for solutions as we implement end-to-end business solutions based on IBM DOC and IBM CPLEX. We have a worldwide presence with offices in France, US, Hong Kong, and Brazil. We have about 40 people, and one of our strengths is the cultural mix. We have 11 nationalities, and we speak 14 languages, and 30% of us is women. Our customers are very international as well. I would say we have a third in Europe, a third in Asia, and a third in America. And I'm sure you will recognize some of the logos on the left. Today, I will focus on Toyota, but if you are interested in any of these references and want to learn more, don't hesitate to contact me or leave your email in the chat, and I will get back to you personally. Now, the Toyota project. So we have created this solution in Toyota Thailand. Toyota Thailand is the third largest producer for Toyota after US and Japan. And it has 5 assembly plants and 4,000 supplier plants, and they move 50,000 pallets per day. So that's a lot. And what we did for them, we created a solution that is meant to optimize the logistics from the suppliers to the assembly plant. And of course, we have to do this just in time and just in sequence according to the Japanese methodology. We have to solve 3 optimization problems to provide the solution. The first one is a 3D packing. So we want to maximize the truck loading. The second is a grouping. So we want to group orders in the same route. And the third one is routing to minimize the distances and the transportation costs. What are the results we got out of the solution? I can say we overachieved our customers' expectations, as they were just expecting a 2% reduction, while we managed to reach a 10 to 15% reduction in transportation costs. Also, it takes just a few minutes to build such a plan, while it used to take a week. So planners now have more time to create alternative solutions, do what-if analysis, and pick the best plan. Also, since we managed to reduce the transportation costs and time, we also managed to reduce the CO2 emissions by 10%, corresponding to about 4 million tons of CO2 emissions per year. Now, let's see how exactly the solution works. So every month, Toyota Japan sends to Toyota Thailand the monthly production plans. So Toyota Thailand knows how many cars they have to produce and how many auto parts they have to order. Now, this is the input of DecisionBrain solution, of our solution. So what we do, the first thing we do is we build a transportation plan that is as similar as possible to the previous month. Why? Because it is proven that if you keep your plan stable, you reduce the risk of accidents. So it's for safety reasons. Once they have this first plan, the planners can select manually or automatically the routes that are the least efficient. For example, the routes where the loading is not, where trucks are not fully loaded. And they can improve these routes. So of course, this is an iterative process where they need to balance transportation costs and efficiency and safety aspects. Now, once they are happy with the plan they have, this becomes a new plan for the month and it is operationalized. For example, this means that to every route and every truck, you need to associate it to drivers, and you need to match driver schedule. So let's jump on the demo now. So during the demo, I will start with the initial solution, so the one that is as close as possible to the previous month's plan. And then I will improve it by selecting the non-effective routes, and I will get to a better solution. Let's see together. So I'm going to log in into the Toyota application. And the first thing I'd like to show you is the initial plan. So this is the plan that is as close as possible to the previous month. And you can see here, you have each line represented truck. So I have 29 trucks, and I can see the routes for each truck. Each route starts and ends at the factory. So each truck will have a journey when they stop to many different points and then get back to the factory. And you can see that most of the times the trucks are doing exactly the same journey, and you can tell because they have the same color. If they weren't, they would be different colors. Now I have many ways to edit this plan. One is manually, so I can easily drag and drop my routes and assign them to a different truck. And then I can run a checker to validate my changes, to validate that I'm not doing anything that breaks constraints. Of course, since I did random changes, I am breaking some constraints, and the UI is pointing this wrong assignment to me. You can see them here. Now I will reset because I don't want to keep these changes. And as a planner, the first time I would want to do as land into a new plan is understand how good or bad it is. So let me move to the route summary. In the route summary, I have some high-level KPI that helps me understanding the quality of my plan. So I have my total cost, and then I have my target cost. The target cost is given by Toyota Japan, and is clearly my objective. And the gap is the distance I have. So what I want to do by optimizing the solution is reducing this gap. Below you can see all the routes. So these are all of my routes, and as I told you, I can select manually or automatically the routes that are not optimal. So for example, where the trucks are not fully loaded. So I can select them manually, or I can just run a task to select the problematic areas, so the not optimized areas, and I can run a task to improve them. Now, I don't want to do this on this scenario because I want to be able to compare my scenarios. So I will first move on the home and duplicate my scenario. So I will run this task on my copy. So I will be working on my copied scenario now. And I will run the task to improve my selection. My task is running and will take about 20 minutes to get to the result, but let me show what the final result will be in a few minutes. So this is my improved scenario. You can see that the gap has been reduced. It's now 13,000, while it used to be 22,000. So now let's see more in detail how this plan is built. I'll move to the loading metrics. In here, I can select a route. And so you remember route was one of the small tiles, blue tiles in the first Gantt chart. And you can see here, I have the details of what is happening in one route. So this view is very interesting to me because it represents visually the just-in-sequence and just-in-time concepts. So each row here represents an auto part. And as you can see, each auto part is uniquely identified by the start location and the end location. What does this mean? It means that I'm not delivering all the auto parts in this route at the entry of my factory, in like something like a stocking point. It means that I'm delivering each auto part at exactly the docking station where it's needed during the production process. And also, as you can see, each column here represents a trip. So I'm doing 8 trips here. This is one done by one truck and one done by a second truck. And you can see that I'm not delivering all the necessary auto parts like just once at the beginning of the day. I'm going back and forth and delivering every time exactly the auto parts that are needed at that stage of the production. And this is the just-in-time concept. And as you can see, the quantity of pallets that I'm delivering in each trip is almost the same, identical. And this means that the load is balanced. Now, one last view I'd like to show you is the 3D view. In here, we can see, if I select a trip and a truck, I can see exactly how the pallets are loaded inside. And I can see it by pallet type or by supplier. So you can see that the truck is very well loaded. And you can see exactly how the pallets need to be positioned inside the truck. And this takes into consideration all of the constraints, such as the loading constraint, when pallets can be stuck and when they cannot, and so on. I hope you enjoyed the demo. And one last thing I would like to bring up to you is that this project was completed in 8 months from conception to deployment. And this allowed us to have a high return on investment and a payback time of less than a year. And one of the reasons why we managed to achieve this result in such a little time is that we leverage many of the out-of-the-box functionalities of our platform, of the platform we are developing, that is also sold by IBM as IBM Decision Optimization Center. Now that's all on my side. If you have any questions or want to learn more about the Toyota project or this platform or any of the other projects I briefly showcased at the beginning of the presentation, please get back to me. My email should be right here, and bye.